Hello and welcome to Mrs. Law's class. In this video, I'm going to show you what happens when we multiply and divide by numbers in linear inequalities. Now, like adding and subtracting, I'm going to start with a little mini investigation. So let's consider the same inequality we had before, which is -6 is less than 9. So is this true? So like before, yes, this is true. So -6 is less than 9. Now, let's take a look at what happens when we multiply the same number to both sides and then still check to see if it's true. So I'm going to start with -6 is less than 9, and then what I'm going to do is I'm going to multiply both sides by 3. So here we have -18 is less than 27. And yes, this is true. The negative number is smaller than the positive number. So still true. All right, so let's do this again. -6 is less than 9, but this time we're going to multiply both sides by a negative number. So we're going to times both sides by -3. So now I have -3 times -6 is 18 is less than -27. So now this time, this is not true. So finally something interesting. So no, 18 is not less than -27. All right, so now let's check what happens when we divide the same number by both sides, and we also want to check to see if this is true. Let's start with the same inequality, and we're going to start with -6 is less than 9, and we're going to divide both sides by 3, +3, and we get -2 is less than 3. So yes, this is still true. Okay, now let's take -6 less than 9. This time we're going to divide both sides by a negative number. We're going to divide both sides by -3. So here we have now -6 divided by -3 is 2 less than 9 divided by -3 is -3. So again, no, this is not true. So 2 is not less than -3. So what we do notice is that when the same positive number is multiplied or divided by each side of the inequality, the resulting inequality is still true. So nothing interesting happens, nothing to do. However, when the same negative number is multiplied or divided by each side of an inequality, the resulting inequality is false. Okay, so both of these examples, when we multiplied by -3 and divided by -3, we got an inequality that was no longer true. Now, to make the inequality true, whenever we multiply or divide by a negative number, to make this inequality true, what we're going to do is we're going to reverse the inequality sign. So for example, in this first one, if we now say that 18 is greater than -27, now this would be true. And in the second one, if we say that 2 is greater than -3, this second inequality would also now be true. So what this means is that whenever we are solving an equation and we have to multiply or divide by a negative number, we need to flip the inequality sign. So let's take a look at a couple of examples. So solve the inequality. So here we have -2x is less than 6. So what we're going to do is, because we want to isolate the x, we're going to divide both sides by -2. So now we have -2 divided by -2, that is x. And then on the right side, we have 6 divided by -2, which is -3. And because we are dividing by a negative number, we need to flip the inequality sign. So instead of less than, it is now greater than. Let's try another example. So in this one here, we're first going to add 2 to both sides. And if you recall, adding actually doesn't flip the inequality. So this is still going to be greater or equal to. And then negative 20 plus 2 is negative 18. Okay, next we're going to divide by positive 9. And because we're dividing by a positive number, we actually don't do anything with the inequality symbol. The inequality symbol still stays as greater or equal to, and this becomes negative 2. So even though our answer is negative, nothing happens to the inequality sign, and that's very important to note. So the only time that we flip the inequality or we change and reverse the inequality sign is when we multiply or divide by a negative number. When we multiply or divide by a positive number, nothing happens. Or nothing changes. Let's take a look at 2 more examples. All right, so here we have 8 minus 2/3 x. So we're going to subtract 8 from both sides. So we're going to move the constant over first. So we now have negative 2/3 x is less than 2. Now when we subtract, don't forget that nothing happens. We don't change the inequality. So now what we're going to do is we need to get rid of the negative 2/3. So we're going to multiply by the reciprocal. So that would be negative 3 over 2. And then don't forget on the right side, we also have to multiply by negative 3 over 2. So this crosses off the 3 and the 2 and the negative signs because negative times negative is positive. So we're only left with x on the left side. And then on the right side, the 2's cross off to become 1, and we only have negative 3 left. And because I multiplied by a negative number, actually, instead of putting a less than symbol, I should erase that and I'm going to put it to be a greater than symbol. Let's take a look at this last example. So we see we have a fraction multiplying by a binomial. So normally we would multiply by the lowest common denominator to get rid of the fraction. But I can see that when I multiply 1/3 and I distribute it into the binomial, both 6 and 24 are divisible by 3. And then in the second binomial, the 6 and the 36 are also divisible by 2. So in this case, I actually don't have to multiply by the LCD because when I distribute, the fractions will cancel off anyways. So I'm going to go 1/3 times 6x, and that's going to be 2x. And then 1/3 times 24, and that's going to be plus 8. And then I have minus 20. And then negative a half x. Sorry, let's put my less than symbol. And then I have negative a half times 6x, which is negative 3x. And then negative a half times negative 36 is positive 18. So let's combine like terms. I'm going to add 3x to both sides. So now I have 5x. And at the same time, I'm going to go 8 minus 20, which is negative 12. And then I have less than 18. I'm going to add 12 to both sides. So I have 5x is less than 30. And then my last step is to divide by 5. And I have x is less than 6. So nowhere down the road have I divided or multiplied both sides by a negative number. So therefore, I never had to change the inequality symbol, so it stayed as less than all the way. And that's how you solve inequalities when you need to multiply or divide.